In dominance, we want to determine which function dominates other. That means which function grows faster than the other function as x goes to infinity. So here, if the limit of x goes to infinity of f of x over g of x equal to 0, that means the bottom function g of x dominates the top function. Again, that means g of x is faster than f of x. And here we have three types of function: exponential function, power function, a log function. You can see from the graph here, the fastest function as x goes to infinity gonna be the exponential function, and then followed by the power function, and the slowest between these two gonna be the natural log, the log function. So here, which function dominates at x goes to infinity, and we are giving x to the power of half and natural log of x. So as we know from previously that the power function will dominate the log function. So now what we want to do, we want to apply the given test. So here, note that g of x, which is the dominant function, gonna be x to the half, and then f of x gonna be the other function, natural log of x. So the test again gonna be limit as x goes to infinity of f of x over g of x, and we want to check if this limit is 0. If it's 0, then the function g of x dominates the function f of x. So now we're gonna take the limit as x goes to infinity. We're gonna have natural log of infinity over infinity to the power of half. This is the same as infinity over infinity, which means we can use the L'Hopital rule in here. So we're gonna use the L'Hopital rule in here. So limit of x goes to infinity of the function natural log of x over x to the power half gonna be the same as limit x to the infinity of the derivative of the top over the derivative of the bottom. Now, what I'm gonna do, I'm gonna arrange these terms. So I'm gonna take this term 1 over x and then over half x to the minus half. And I'm gonna write the minus half as a term of a fraction. Now, this is the same as 2x to the half, so I brought the bottom up, and then the same top is the same, gonna be 1 over x. Now this is as 2x half over x, and then the power can be subtracted. So it's gonna be 2 multiplied by x to the minus half, which is the same as 1 over x to the half. Now, this whole messy term of a fraction can be written as 1 over x to the half. Do not forget the 2 in here. This fraction gonna be multiplied by 2. So now we are ready to take the limit. As x goes to infinity, it's gonna be 2 over infinity, which is gonna be 0. Therefore, x to the power half dominates the other function. Now we have x to the 5 and 0.1 x to the 7. This is two power function. However, the higher power will grow faster than the lower power. Therefore, x to the 7 will dominate x to the 5. Now we want to apply the test. So the test is gonna be limit as x goes to infinity of x over g of x, and we want to check if the limit equal to 0. If yes, then the function g of x, which is the dominant, which is 1.1 x to the 7, will dominate the other function, which is f of x, which is gonna be x to the 5. So now I'm gonna take the limit as x goes to infinity. That's gonna be infinity and then over infinity. Therefore, we can use the L'Hopital rule in here. So I'm gonna take the derivative of the top and then over the derivative of the bottom. Again, this is the same. I'm gonna take the limit. When I take the limit, it's gonna be infinity over infinity. I'm gonna use the L'Hopital rule again. Now I'm gonna take the limit again. So I'm gonna take the derivative of the top and then the derivative of the bottom, and gonna be the same. Infinity over infinity. If I take the limit, and again, then I can use the L'Hopital rule. So here we can notice if we take the derivative of each, we reach to a point where on the top we have a fixed number, and then the bottom we have x, or x squared, since the power is 2 higher than x to the 5. So number over infinity is just 0. Therefore, this limit gonna be 0, which means 1.1 x to the 7 will dominate. Now for 3, we have these two functions, natural log of x plus 3, and then x to the 0.2. So here we know that the power function will dominate the log functions. Again, we want to test this, so we want to test the limit as x goes to infinity of x over g of x if it's gonna be 0. So here of x gonna be the first function, natural log of x plus 3, and then g of x gonna be the dominant function. It's gonna be x to the power 0.2. Now I'm gonna plug these two functions into the limit. I'm gonna take the limit. So the limit here gonna be natural log of infinity over infinity to 0.5, which is the same as infinity over infinity. Therefore, the L'Hopital rule applies in here. So I'm gonna use the L'Hopital rule in here. I'm gonna take the derivative of the top, which is 1 over x plus 3, and the derivative of the bottom, which is gonna be 0.2x to the power of 0.8. Now I'm gonna take this whole fraction and I'm gonna try to simplify this fraction. So 1 over x plus 3 can become written as this way, and then we have the other fraction. So here what I'm gonna do, I'm gonna multiply top fraction and bottom fraction by x to the power of 0.8. That's gonna be x.8 and then over 0.2, since x.8 over x.8 gonna be 1. Now this is written as the same as x to the 0.8 and then 0.2 x plus 3 if we multiply the two fractions together. Now I'm gonna substitute for the messy and larger fraction by what did we just found. Now I'm gonna take the fraction as x goes to infinity. Here we will have infinity over infinity, which means we're gonna use the L'Hopital rule again. So this is the limit as x goes to infinity of x.8 over 0.2 multiplied by x plus 3. Now the L'Hopital rule. So what I'm gonna do, I'm gonna take the derivative of the top and then over the derivative of the bottom. Now 1 plus 3 is 4. 4.2 multiplied by 0.2 is 0.8. So the limit will be limit as x goes to infinity of 0.8 x to the power negative 0.2 over 0.8. So the 0.8 will cancel each other and we'll left off with x to the negative 0.2. And then we can write that in terms of a fraction, and then we are ready to take the derivative, to take the limit. So the limit will gonna result in 1 over infinity, which results in 0. Therefore, the power function will dominate.